Welcome to VLSI Drilling channel. Today we will study about blocking and non-blocking assignments. Let us study first blocking assignment. Blocking assignment statements are assigned using equal operator and are executed one after the other in a procedural block. This doesn't prevent execution of statements that run in a parallel block. The value on right hand side is assigned to target on left hand side immediately. For example, always at the rate passage clock 1, begin data 1 equal to 1 tick B1, data 2 equal to data 1, data 3 equal to data 2, end. So we are making use of blocking assignment here. The value 1 is assigned to data 1 in the first line because it's a blocking assignment and it blocks the other statements till data 1 is assigned 1. Then in the second line, data 1 is assigned to data 2, which is the value 1. And in the third line, data 2 is assigned to data 3, that is also equal to 1. So the blocking assignment immediately takes the value in the right hand side and assigns it to left hand side. The value 1 immediately propagates to data 3. Now let us study non-blocking assignments. Non-blocking assignments less than equal to are used to model parallel assignments in a procedural block, usually within a clocked always block. The value on the right hand side is evaluated, but the actual assignment to the target on the left hand side is deferred until the end of procedural block. Let us understand through an example. So here we are making use of non-blocking assignments. Now here value 1 is assigned to data 1 at the end of procedural block. So data 1 value remains x by that time. So at one clock cycle, after one clock cycle, data 1 is getting assigned 1. Then in another clock cycle, data 2 will be assigned data 1, that is 1. And in another third clock cycle, data 3 will be assigned data 2 with value 1. So it will take 3 clock cycles for the value 1 to propagate from data 1 to data 3. So unlike blocking assignment, it will take more number of clock cycles for propagating the value. Let us see difference in a nutshell. When we see the evaluation order for blocking assignment, it is sequential, while for non-blocking assignment, it is concurrent. When we see the order of execution for blocking assignment, it is in the order they appear one by one, while for the non-blocking assignment, it remains concurrent without specific order because all the assignments take place at the end of the procedural block concurrently. Usage in a combinational logic. So it is suitable for both blocking and non-blocking assignment to be used in combinational logic. Usage in sequential logic. So for blocking assignment, it's not suitable, but for non-blocking assignment, it is suitable to use in sequential logic. And regarding delay, there is no inherent delay in blocking assignment because the value at right hand side gets assigned to left hand side immediately. But in case of non-blocking assignment, there is inherent delay, usually 1 clock cycle. Syntax we know, equal for blocking assignment and less sign and equal sign for non-blocking assignment. For example, A equal to B plus C for blocking assignment, while Q getting assigned D with non-blocking operator is shown here. Behavior. So blocking assignment, it evaluates right hand side and assigns immediately, while non-blocking assignment evaluates right hand side but assigns at the end of the time step or always block. Recommended use for blocking assignment combinational logic, for non-blocking assignment sequential logic. We need to pay special attention here. It is important to understand the difference between blocking and non-blocking assignments, especially in synchronous digital design, because using the wrong type of assignment can lead to unexpected behavior and simulation mismatches. So as we saw in previous examples, with the change in blocking and non-blocking operators, the result of the simulation vary a lot. So we need to take care. In Verilog, generally if creating sequential logic, then we need to use clocked always block with non-blocking assignments. If creating combinational logic, then we should use an always block with blocking assignments. And we should not mix the two in the same always block. So this is the general things that are taken care while using blocking and non-blocking assignments. Now get ready for the small test, which will comprise of questions that can be asked in Verilog interviews or written test. So here is the first code. Please go through it. Module blocking test. So here inside initial begin end block, we are giving a equal to 1, b equal to a, and dollar display a and b. So please tell what will be the values of a and b displayed here. Your time starts now. So pause the video here and try to guess the values of a and b. I am running the simulation. So here, as we were using blocking assignments, so when we did a equal to 1, 1 got assigned to a immediately. Then after doing b equal to a, the value 1 which is assigned to a gets assigned to b immediately. Hence, when we do dollar display, it will display a equal to 1, b equal to 1. Now let us go for second question. So here we change the blocking assignment to non-blocking assignment. Now tell what will be the values of a and b displayed here after the simulation. Your time starts now. You can pause the video and try to solve the question. I will run the simulation now. So let us check the answer. So here a is getting assigned value 1 through non-blocking assignment, but it actually gets assigned at the end of the procedural block. So the value of a remains x for now. Then we are assigning we are assigning a to b through non-blocking assignment, but the value a is not yet 1 and b still remains x. So when we do dollar display a and b, a equal to x, b equal to x comes. A equal to 1 will become only after the end of the procedural block. So hope you all understood the question and the solution. So let us move to the another question. So here we are initializing count with value 0, 0, and then we are displaying the initial value of count. Thereafter we are incrementing count by 1, count equal to count plus 1, and then we are displaying the value of count after increment. So now tell what will be the values of count that will be displayed after simulation in both cases. Your time starts now. You can pause the video and think for the solution. So I am running the simulation. So here, because we are using blocking assignment, so count gets assigned value 00 immediately, and the dollar display will show count value as 00. Now we are incrementing the counter using blocking assignment, count equal to count plus 1. So here also count is equal to 00 plus 1. So new count value gets assigned 1 value. So the count after increment will show as 01 in the second dollar display. So the answers will be 00 and 01. Now moving to another question. So now let us change these blocking assignments to non-blocking assignment. Now tell what will be the values of count displayed in each case after the simulation. Your time starts now. So pause the video and think on it. So I am running the simulation. You can check the solution. So here, because we are utilizing non-blocking assignment, so count will not receive the value 00 immediately. It will get assigned at the end of the procedural block. So the count value remains XX here for the first dollar display. Then we are incrementing the count value by 1, but the initial count value is not updated to 00 yet due to non-blocking assignment nature. So it remains X, and the new count value also remains X after the increment. The count will get the 00 value, updated value at the end of the procedural block. So here for the both dollar display, count will be displayed as XX in both cases. Hope all these questions help you in understanding the concept better. So the key difference is that non-blocking assignments allow for concurrent updates and represent a more appropriate modeling of sequential logic elements like counters and flip-flops in hardware description languages like Verilog. So both operators are very helpful and we can utilize them as per our design. So keep learning, and we will be coming up with lots of more conceptual videos. Don't miss any video. Like and subscribe VLSI Drilling. Thank you.